that he requested from Stanford and brought them back, hand-carried them back, as well as on a computerized disc, which is now on our website. You can see it. He looked at it and he said, well, first of all, there is no form of dwarfism or genetic defect that explains everything seen in this being.
So one of the first things that Dr. Lockman immediately remarked upon was the shape of the head and the skull. It was not something that he is accustomed to seeing. Certain aspects of the skull and certain aspects of the potential mutations and syndromes that might account for the specimen were present. But what was remarkable, at least in my discussions with him, that any given syndrome often has co-phenotypes or co-events that would occur. And it was quite interesting and in some ways exciting as he would remark upon a particular feature of the specimen and then find that the associated features that you would expect from a syndrome of that nature were not found.
What you'll also see is that he says it has 10 ribs.
Occasionally there are human mutations where there's perhaps 11 ribs, but only rarely is it ever seen that there is 10, and then never are those kinds of mutations seen associated with the other features of the skull and or face. So again, if this is human and it has a constellation of mutations that have not been seen before, doesn't discount that it might be such a constellation of mutations, but it's just that they've never been seen before.
What he didn't notice, but I will point it out to you, it has 4 skull bones rather than the 6 major ones we have. It's symmetrical, and the symmetry is what's also very important. The only asymmetry I want to point out, which is mentioned in Dr. Lockman's report, is the fact that it had a terrible blow to what we would call our right mastoid air cell area of the skull that crushed the skull and kind of torqued the whole skull, and also a fracture of the right humerus. The epiphyseal plates, if you look at the x-ray, which is the growth plates. You know when you have, the growth plates in a kid and they hurt their leg? The growth plates and the bone density is that of a 6 to 8-year-old.
The idea here is that in the growing knee or in the growing joint, mostly it is made of cartilage. And that you get a mineralization of the cartilage and a continued growth of this so-called growth plate. There are standards, right? There are expectations that you will have the growth plate be of a certain size for a certain age. The shock, I think, and the surprise was, and the absolute certainty that Dr. Lockman had was that this specimen was clearly not fetal.